Good morning, students. We are down to the last 4 weeks of our lesson. So I'd like you to bring out your notebook, pencil, and your ball pen so you can take down notes of some important details about today's lesson. The lesson for today is trigonometric identities. And at the end of the lesson, you must be able to verify trigonometric identities. When we talk about trigonometric identities, in one variable, it's a trigonometric equation that is true for all values of the variable. These are all basic identities. The first part, we have the reciprocal identities. The reciprocal of cosecant theta is 1 over sine theta. Sine theta, the reciprocal is 1 over cosecant theta. Secant theta, the reciprocal is 1 over cosine. Tangent theta, the reciprocal is 1 over cotangent. And then the bottom part, we have the tangent identity and the cotangent identity. Please take down notes of these basic identities because we are going to use these basic identities to solve the next example. Um, so let's start with number one. What is the domain of validity of each trigonometric identity? Cosine is equal to the secant theta. Um, let's graph that in Desmos and let's see what is the graph look like. So let's start with um, we have y equals cosine theta. So cosine, and then this is theta. The second one is you have to express your answer into a fraction. I mean the problem into a function, so we can use Desmos. Y is equal to secant theta. Our theta is this one. So this will be the graph. The purple one is the secant theta. The green one is the cosine theta. Notice that the graph of the domain of the cosine, which is the green one, is the set of all real number. However, the domain of the purple graph, which is the secant theta, it's undefined in a multiples of pi over 2. Um, I was able to crop a portion of the graph, this one. So the secant theta, that's the red one, the blue one is the cosine theta. So the domain there of cosine theta is all sets of all real number. Whereas the domain of 1 over secant theta excludes all zeros of secant theta. Okay? Because all secant theta is undefined at the odd multiples of pi over 2. So this one. They are the secant theta is undefined in odd multiples of pi over 2. So therefore, the domain of cosine theta equals 1 over secant theta is equal to all real numbers except for the odd multiples of pi over 2. Since pi over 2 or in pi over 2, secant theta is undefined. Okay, for number 2, 1b rather, secant theta is equal to 1 over cosine theta. The domain is the same with number 1 letter A, because secant theta there is not defined for odd multiples of pi over 2. And the odd multiples of pi over 2 are the zeros of cosine. So the domain here is the same in number 1 as all real numbers except for odd multiples of pi over 2. Since pi over 2 there, the secant theta is not defined. Okay, let's have number 2. Let's verify the identity. What's the domain of the validity for sine theta? Secant theta is equal to tangent theta. So sine theta, secant theta, we're going to simplify the right side because it would be easier for us to do the tangent theta. We can rewrite that as sine theta multiplied by cosine theta. Remember that tangent is sine theta over cosine theta, which is equal to tangent theta. So this is the sine. Secant is the reciprocal of 1 over cosine. By multiplication, sine theta times 1 is sine theta over cosine theta. And we know that the trigonometric identities for sine theta over cosine theta is tangent theta. So the domain of sine theta there is all real numbers, whereas the domain of secant theta and tangent theta excludes all zeros of cosine theta. So these are the odd multiples of 2. Okay, cosine theta, which are odd multiples of pi over 2. So in other words, therefore the domain, I have to write down everything. The domain of validity is the set of all real numbers. However, there is a restriction: set of all real numbers except the odd multiples of pi over 2, since cosine theta is not defined in the odd multiples of pi over 2. So this is the answer. And this one. Okay, let's do the last one. 1 over cotangent theta is equal to tangent theta. So 1 over cotangent theta, tangent theta is equal to 1 over tangent theta. The definition of cotangent theta. So by simplifying this, we have 1 over cotangent theta is equal to tangent theta, which is equal to tangent theta equal to tangent theta. So the domain here, the domain of cotangent theta excludes multiples of pi, because at 180 and 360 cotangent theta is undefined. So also cotangent theta is equal to 0, the odd multiples of pi over 2. So therefore, since we have the domain for cotangent theta there, the domain of validity is all sets of real numbers except the multiples of pi. Wait a minute. Except for, I'm sorry for it, it should be pi over 2, not pi. So, pi over 2. Okay. After the video, you have to answer the practice exercises in your Go formative. And after the practice exercises, you'll have to submit your classwork 14.1 trigonometric identities.